Greetings, everybody. Today we're kicking off scientific notation. We don't plan to spend a lot of time on scientific notation. It's very highly linked to exponents, but it is very important, and it's something that you'll see throughout your math career and in science class as well as you go forward into high school. So, what is scientific notation and why is it important? Well, scientific notation is a number written in this format right here, a times 10 raised to the n power. The base is always 10, and as you can see right here, a always has to be between 1 and 10, greater than or equal to 1 and less than 10 for a. Scientific notation is super helpful for expressing really big numbers and really small numbers that we don't want to have to write out with all the extra zeros. So scientific notation is very practical in that sense, and it helps us save time. This notes packet that I'm going through right now is available on Schoology. The key is also available on Schoology. So per usual, I'm just going to go through some examples here, and you guys can follow along by just watching the video. You can have the key up on your Chromebook as well if you want to kind of look at the key as you go, because I'm not going to do all the examples, just some of them. So this first slide, though, will give you a good kind of baseline of what scientific notation is. If you had something like 5 times 10 to the third power, that could be rewritten as 5 times 1,000. How would you get 1,000? Well, 1,000 is the same as 10 to the third power, right? 10 to the third power is 10 times 10 times 10, which is 1,000. That's how that got there, right? And 5 times 1,000 is 5,000. If I did 5 times 10 squared, that would be like 5 times 10 times 10. 10 times 10 is 100. 5 times 100 is 500. If I did 5 times 10 to the first, that's like 5 times 10, which is 50. Notice a pattern here? 5 times 10 to the 0. 10 to the 0 is just 1. Remember that from last unit? Anything to the 0 power is just 1, so that's 5. 5 times 10 to the negative first power. Well, that's like 5 times 1 over 10, which is 5 tenths, which is 1/2. And 5 times 10 to the negative second is 5 times 1 over 10 squared. That's like 5 times 1 over 100. 5 times 1 over 100. And that is 1 over 50. Now 1 over 50 is the same as 0.05. And if I backed up to 1/2, that's the same as just 0.5. Interesting. 5 times 10 to the negative third, last one, that's 5 times 1 over 10 to the positive third power, which is 1 over 200, which is 0.005. Look at the pattern here, folks. I'm going to switch colors here. What's happening every time we go to a new row? What's happening? From 5,000 to 500, that's division by 10, right? From 500 to 50, that's division by 10. From 50 to 5, 50 divided by 5, or excuse me, 50 divided by 10 is 5, so division by 10. Every time you go to a new row, you're dividing by 10. There's a reason for that, and the reason is this. The base of all of these is 10. So as the base of 10 decreases by 1, the number gets 10 times smaller. That makes sense. Every time your base of 10 increases by 1, your number would get 10 times larger. So that is a little experiment and a little foundation work with scientific notation. Let's talk a little bit about how we can express numbers written in standard form, which is just a regular way of writing numbers, into scientific notation. Here's an example right here. Notice how you can write the number 384,000 as 3.84 times 10 to the fifth power. How in the world would I get that? Let's zoom in on this a little bit. Notice how the decimal point for 384,000 is currently after the last zero right there. Look how many spaces I have to move my decimal point in order to get my first number between 1 and 10, which is the rule for scientific notation. So you may suspect you're going to have to stop right there between the 3 and the 8 to make that number between 1 and 10. So look how many spots you have to move it. 1, 2, 3, 4, 5 spots you have to move it, which is where the 5 comes from right there. You had to move the decimal point 5 spots to the left, so it's 10 to the fifth power. Your base will always be 10, and your power is determined by how many spaces you have to move. Because we move to the left in this case, it's positive. but it could be negative if we're moving the other direction to the right. And 3.84 is the result of moving that decimal point 5 spaces. You have 3.84 after that. This number right here, if I put it in my calculator, and this number right here are exactly the same. One is written in scientific notation, one is written in standard form. Let's practice writing these numbers in scientific notation. So for letter A, my decimal point is currently right here after the last 0. How many spaces do I have to move that decimal point to get my number between 1 and 10? Well, I need it to end up right here between the 3 and the 7, right? Because 3.7 is between 1 and 10. So how many spaces do I need to move it? 1, 2, 3, 4, 5 spaces. So my answer is going to be 3.7 times 10 to the 5th power. Let's take a look at the next one. Decimal point's currently right there. I need it to end up where? Between the 5 and the 2, don't I? So how many spaces? 1, 2, 3 spots I have to move it. So notice what I'm going to write here. 5.281, I have to include all those numbers, times 10 to the 3rd power. Lastly here, I want to convert this distance of 93 million meters into scientific notation. So how would I write out 93 million? Well, 93 and then 6 zeros, that would be 93 million. Currently my decimal place is right here. I need it to end up between the 9 and the 3 in order for that first number to be between 1 and 10. So 1, 2, 3, 4, 5, 6, 7 spots I have to move it. I'm going to say 9.3 times 10 to the 7th power. Well, what if I'm going the other direction? What if I have something like part 3 example, part A, where I have 6.34 times 10 to the 5th power? That's in scientific notation. I need to convert it to standard form. So the first step is to write out 6.34 as it currently appears. And this 10 to the 5th power means that I'm going to have to move the decimal point 5 places to the right. If I'm multiplying a number by 10 to the 5th power, that number is getting significantly larger. If a number is getting larger, its decimal point is moving to the right. So 1, 2, 3, 4, 5. Put zeros in the blank spaces. And there's my new number. 634,000 is my number. Why don't you guys try the next one? You can pause the video if you'd like. You start out with 3. And it's times 10 to the 7th. So 1, 2, 3, 4, 5, 6, 7 spots to the right. Fill in with zeros in the little dips. There is where you write the zeros, not on the points, but in the dips. So 30 million is your number for that one. Here's a word problem. We want to convert this distance into standard form. So currently it's 2.4 times 10 to the 5th, so I need to move 5 spots to the right. 1, 2, 3, 4, 5. Fill in with zeros. 240,000 would be your answer for that one. To this point, we've just been looking at really big numbers, converting those into scientific notation and from scientific notation into standard form. Now, scientific notation is also super helpful for really small numbers. Look at this example right here. We have a number 0.000234. I can convert small numbers to scientific notation too. Notice how I have to move 1, 2, 3, 4 spots to the right in order to make that first number between 1 and 10. 2.34 is what goes here. And then I had to move 4 spots to the right. So when you move to the right, it's going to be a negative number, so a negative 4. How can you always tell if it's going to be positive or negative? If your number is a really small number like this power is always going to be a negative. It's really as simple as that. If this number is really big, then the power will be positive. Let's try example 1 and look at A and B here. So currently here's my decimal point. Where do I need my decimal point to be if I want the first number to be between 1 and 10 for scientific notation? Would it work if it was all the way after the 7? 574 or 547 is way too big. What about 54.7? Oh, that's still too big. What about 5.47? There it is. Okay, so let's see how many spots I need to move. 1, 2, 3, 4, 5 spots. So 5.47 times 10 to the negative 5th. If you want to pause the video and try B before you continue, feel free to do that. I'm going to go ahead and look at B now. All right, I need my decimal point to end up after the 6. No, 76 is too big. What about 7.6? There is my spot. So let's go 2 spots to the right. So that's 7.6 times 10 to the negative second power. All right, let's go the other direction. So here's an example of a number written in scientific notation, and we want to convert it to standard form. So if I have a negative power, like a -3, that means I'm making the number smaller. So I'm moving the decimal point 3 places to the left. As you can see here, here's where it starts, 1, 2, 3 spots to the left, and here's my new decimal point. So I have 0.00132. It's a small number that you found by moving the decimal point 3 places to the left. Let's take a look at some examples down here. 1.27 times 10 to the negative sixth. All right, I'm going to write 1.27 first, and I'm going to move the decimal point 6 places to the left in this case. 1, 2, 3, 4, 5, 6. There's my new decimal point. Fill in zeros in the gaps. So my new number is 0.000000127. That's my new number. I'm going to do B. If you want to pause the video and try it on your own first, feel free. So 4 times 10 to the negative eighth. Note that currently 4 is really the same as 4.0, right? You can think of it as 4.0. And the decimal point's after the 4. So if I want to the negative eighth power, I need to move this 8 places to the left. 2, 3, 4, 5, 6, 7, 8. So I'm going to fill in 7 zeros. So it's point, and then 7 zeros, and then a 4. You can put the last 0 there if you want, but you don't need to. After you hit a number, if there's just zeros after it, you don't have to include those zeros. Let's look at an example. Example 4 here, a word problem. 1.23 times 10 to the negative second power. We need to convert that into standard form. So I need to move 2 places to the left. 1, 2. So my new number is 0.0123. What about the one below it? So here is my number that I have to convert here. So I'm going to write it out, 7.0 times 10 to the negative sixth. Let's move 6 places to the left. 1, 2, 3, 4, 5, 6. I'm going to fill in zeros. 1, 2, 3, 4, 5 zeros. So my new number is 0.000007. That is the diameter of a red blood cell in standard form. All right, I'm going to pause here for a moment. If you want to practice a little bit on the first 4 pages of the notes, feel free to do a few examples. Check your answers on the key. I'm going to produce another video for operating with scientific notation next. So I'm just going to kind of split the lesson today into 2 shorter videos. So you're free to watch them both right now or take a little break and come back to the other video in a second. As always, if you need anything, please reach out.